Hello everyone, welcome back. Today we're going to be looking at relative age dating, which is a process that geologists use to compare the age of different layers of rocks. And it's important to understand what this is, and maybe even more important to understand what relative age dating is not. So relative age dating would allow us to compare, let's say, this bright angel layer of rock, compare its age to the mauve layer of rock here. But we wouldn't be able to tell how old each layer actually is. All we would know is that the mauve layer is younger than the bright angel layer, that the bright angel layer is younger than the tapetes layer. So this doesn't tell us how old each layer is, but it does inform us compared to one another, which one is older or which layer is younger. And there's a few rules, laws that we're going to be looking through on how we do that. So let's go ahead and get started. So again here, just re-emphasizing what was already said. Relative age dating allows us to determine how old rock layers are compared to one another. So only compared to one another. Relative age dating does not allow us to know how old the rock layers actually are. So for example, I could say that layer A is older than layer B because it's underneath layer B, but I don't know how old layer A and layer B actually are. Next, we'll look at some of the actual laws that help us determine the relative age of rock layers. So here's a list of the main laws. This is not a comprehensive list, which means there's some other laws that we're not going to discuss in our class. And also any law that has an asterisk next to it is going to be more of a main focus for this class. We're not going to go into depth on every single one of the laws used to determine relative age. But we're going to look at the law of superposition, the law of original horizontality, the law of cross-cutting relationships, and then lesser we'll look at the law of included fragments. That doesn't mean it's not important, it's just not something that we're going to focus on in this class. Let's go ahead and start with the law of superposition. The law of superposition states that new rock layers must form on top of older rock layers. So that's suggesting that this rock layer down here would have been laid down first. The sediment would have fallen from a river or a lake or an ocean. It would have settled at the bottom, and then over time newer sediment would have formed on top of that, and then eventually newer sediment on top of that. When you guys remember playing around with the This Is Sand simulation, that's what you would have seen as well. Every time you switched colors of sand, it's going to be on top of the previous layer. So the law of superposition allows us to say that the further down that you go in a rock strata or a layer of rocks, the older it gets. The further up you go in a rock strata, the younger that rock gets. Once again, it doesn't tell us how old the oldest rock is or how young the youngest rock is. We just know that it's older down below and younger up top. And once again, that is the law of superposition. Really going hand in hand with the law of superposition is the law of original horizontality. What the law of original horizontality tells us is that new rock layers form in almost horizontal or almost completely horizontal layers. And this is due to gravity. Gravity is a force that's pulling things down towards the center of the Earth, so everything on the surface of the Earth naturally wants to form horizontal levels. So originally, these sediments are horizontal, and this allows us to find some things that are unconformities. For example, if we find layers of rock, that I'm going to zoom out here for a second. If we find some layers of rock that are tilted, so we have rock layers that are tilted like this, we know that's not how they originally formed. They would have originally formed horizontally, and that means that something must have rotated those rock layers. And usually that's something like tectonic plate motion or an earthquake. But if we zoom back in on this picture, we see another thing that can change the horizontal nature of a rock layer. So if we focus on this picture, let's focus on this brown layer at the bottom, this brown layer here. We know that originally that layer, the law of original horizontality tells us that layer would have been horizontal. It would have extended in a straight line all the way across. It must have been eroded away, whether it was a glacier or a river or wind. Something eroded this rock material down, weathered that rock material down and eroded it away. And then we see new rock layers formed on top of it. And it's important to look at the whole layer here because the law of superposition tells us that this yellow layer is above the brown layer. So when we look at the full column here, we know that this yellow layer is younger than the brown layer. But if you just look at the topmost parts, well, the brown layer extends above the yellow layer, but that doesn't mean that it's younger. This formed first. We know it had to have been horizontal, and then it was weathered down and eroded away, and then eventually a new layer of sediment filled in a horizontal nature. So looking at this section of the column, we can see that the brown layer is older than the yellow layer due to superposition. So again, it's important to remember that layers originally form horizontally, as stated by the law of original horizontality. All right. Up next, we're going to look at the law of cross-cutting relationships. So the law of cross-cutting relationships refers to usually volcanic intrusions into existing rock layers. And there's lots of different names for these. We have some horizontal sills here. We have a large batholiths. Dikes will come up through. But these are volcanic igneous rock intrusions, and they don't follow that law of original horizontality, and that's because there's already rock layers in place. So if we were to take a look at this laccolith over here coming up, we can see a volcanic intrusion that's being forced up through weak spots in the rocks layers above until it finally reaches a layer where it can spread out more horizontally. But if these other layers were not already here, this volcanic layer would have spread out horizontally to begin with. So that means we know the layers were already existing around this cross-cutting concept before it came in. So that tells us that the cross-cutting concepts are younger than the layers that they cut through. So this laccolith is younger than all of the rest of the rock. This batholith is younger than all of the rest of the rocks because they are cutting through the rocks. Now imagine if there is another layer cutting through this batholith. So what if we had a new layer that came cut through again, and it was clearly shown cutting through this batholith? Well, then that would mean this layer is even younger than the other cross-cutting concept. So things can cut through other layers and that other cross-cutting concepts. And the thing that cuts through is always younger than the thing that is being cut through. So the cross-cutting concepts are always younger than the rock layers that they cut through. Last law is going to be quick. It's going to not be a main focus of our class, but it's the law of included fragments. And this is not for large cross-cutting concepts, but like solitary chunks of rock. So if we look in this rock, we see a smaller chunk of rock nestled inside of it. And this idea states that this law of included fragments states that this rock is not going to form inside an already existing rock, which means the rock on the inside has to be older. So this is the older rock, this is the younger rock, and that is the law of included fragments. Let's take an opportunity now to put a lot of this information together. You should recognize this image from the mud puddle relative age dating worksheet that you did before getting to these notes. But let's put these laws all together in a uniform way, ordering these layers from youngest to oldest. And we're going to start with the oldest layers and work our way up. So we're going to work our way up. Well, looking at the laws of superposition here, it's pretty easy to compare H to G, G to F, F to D, D to B, B to E, and E to A. But we can't just look at that. We need to look for cross-cutting concepts and everything else too. But remember, cross-cutting concepts are younger. So even though C is cutting through H, G, and F, it's not older than H, G, and F, it's younger. There's a fault cutting through this from an earthquake that is also younger than the surrounding rock layer. So we can pretty conclusively say that H is our oldest layer according to the law of superposition. Next up would be G. G is going to be the next oldest layer from superposition, followed by F. So we're still only dealing with superposition. Now, it's pretty clear that after F, we've experienced some tectonic plate motion. These layers are no longer horizontal. Tectonic plate motion has tilted these layers, and then often associated with tectonic plates, we see an earthquake that has caused this fault. So this fault line here has disrupted layers H, G, and F, which means it's younger than H, G, and F. The fault did not disturb layer D at all, so we know that it happened before layer D existed. So the next thing that happens here is that fault. The fault, that earthquake, EQ for earthquake, was the next thing to occur. Back to superposition for the next one, we have level D. Layer D formed from superposition, and it might have formed much later in time because this is now horizontal again, so the tectonic plate motion that was disrupting these seems to have stopped or lessened at that area, and now we have a new horizontal layer that has formed in D. But again, we don't know how long these layers take to form. They can form at different rates. So it doesn't mean that layer D is millions or many millions of years younger. We just don't have that information based on relative age dating. We now have a cross-cutting concept in layer C. It's cut through H, it's cut through G, it's cut through F, and it's cut through D, which means it is younger than all of those layers. It has not cut through layer B, which means it is older than B. So we know it's younger than D, but older than B. So next we have C. After C, based on superposition, we go to layer B. Based on superposition, again, layer E, and then finally layer A. So that's how you can look through a rock strata, these layers of rocks, using those laws we just talked about, and determine which layer is the oldest and which layer is the youngest. But again, we do not know how old these layers actually are. That's going to be touched on in our blue square activities with absolute age dating. As always, if you have any questions, feel free to ask. See you in the next video. Thanks.